So today I am on 292, and it says there, today we're going to talk about complex numbers. We talked about real numbers. You know what real numbers are, like 5 and 100 and just a regular old number. And you know what imaginary numbers are. We've been looking at those in the last couple of days. A 6i and a 2i, those are imaginary numbers. Well, today we're going to talk about complex numbers. And a complex number is something like this. It's a value that has a real number part, and then it has an imaginary part. If you put those two together, we call it a complex number. Complex number has a real portion and it has an imaginary portion. So what we're going to do today, add, subtract, multiply, divide complex numbers. And in most cases, you would treat this I as if it were any other variable, like an X or a Y, right? You do the same thing you would do as if it were an X or a Y. One thing, when you write this, when you write a complex number, we usually put the real part first and then the imaginary part. It's technically correct to put the real part and then the imaginary. If you happen to write this 7i plus 5, I would probably let it go, you know. But technically, you're supposed to put the real part first, then the imaginary. So, starting with adding, if you're going to add things like that, do you actually really even need the parentheses? No. This is really just 3 plus 6i plus 4, take away 2i. And then you just combine the like terms. I've got a 3 and a plus 4, 7. I have 6i, take away 2i. And that's my answer right there. That's not very difficult, is it? Subtracting, remember, the only thing you need to remember is this minus sign goes with both of those. The first complex number, you leave that one alone. And here you subtract the 4. Everybody always remembers to subtract the 4. But then don't forget, you also have to subtract this negative 2i. What do you get when you subtract negative 2i? You add it. And then once you do that, once you change the signs, now you just combine like terms again. So I've got a 3 take away 4, negative 1. And then I have a 6i plus 2i. And there you go. That's your answer, negative 1 plus 8i. That's not too difficult either, right? Just like, you know, if you had x's and y's, you have to combine the number part with the number part and the variable part with the variable part. That's it. So already we did add, subtract. Multiply. You know how to FOIL, right? So that's what we're going to do. We're going to FOIL. Start here. What's 3 times 5? And then move over 3 times 2i. And then you're going to move over and do the 4i times 5. Didn't leave much room. What's 4i times 2i? 8i squared. So I've got some like terms right there. 15 plus 26i. Now, the only difference is I squared. What is I squared again? I squared is negative 1. So right here, we can replace the I squared with -1, which means that's going to be a -8 then, right? If we multiply. And now you can combine the 15 minus 8. Looks like 7 plus 26i, right? So the only difference between this and regular foiling, it is regular foiling, but at the end you have to replace the I squared with the -1. That's not too bad, right? Questions so far? This one, everyone always wants to say that's 9 plus 16i squared. Squaring, what does squaring mean? Multiply by itself. There is no shortcut. You have to write it out and FOIL it. There is no shortcut. So let's FOIL it. What's 3 times 3? 9. 12i? 12i? And then 4i times 4i, 16i squared. Right here I have some like terms. 12i, 12i, 24i, and 16i squared. What is I squared equal to again? -1. So I have 9 plus 24i, take away 16. 9, take away 16. -7? -7, and then I have the plus 24. Does that make sense? FOIL it again. Before I do this one, look at the two quantities we're starting with. See the two quantities I'm starting with? Anybody remember the name for that? They're the same quantities, but they have an opposite sign in there. What's the name for that? What's the name for that? Same quantities, but opposite signs. Starts with a C. C-O-N. Conjugate. Conjugates. They're conjugates. Same quantity, but opposite sign. And something happens when you multiply conjugates. Watch what happens. 9 minus 12i. Move over. Plus 12i. And then minus 16i squared. What happens when you multiply conjugates? What is I squared? Remember, positive 12i and negative 12i drop out. So I get 9 plus 16, right? What is 9 plus 16? 25, I think. So what happens when you multiply conjugates together? The I term drops out. What happens when you multiply conjugates? Every single time you multiply conjugates, the I goes away and you end up with just a number. Now, why did I point that out? Well, because over here, if this is my problem, I'm not allowed to have I in the denominator. And remember a while back, we did some problems where you'd have 5 take away root 2 and 3 plus root 3. And remember, we weren't allowed to have square root in the bottom. So when it was more than just a root, if it was just root 3, we'd multiply by root 3 and root 3. But when we have two terms here, the way that we got rid of that, do you remember? We multiplied by the conjugate. Top and bottom, we multiplied by the conjugate. Does anybody remember that? Same quantity, opposite sign. Well, that's exactly what we're going to do here when you have two terms. Yesterday or the day before we did, if you just had 3i, you multiply by I over I. But now that I have two terms, I'm going to need to multiply top and bottom by the conjugate of the denominator. We don't care about the numerator. You can have whatever you want in the numerator. But you cannot have an I in a denominator. And when there's two terms, you're going to have to multiply by the conjugate. 2 minus 3i. Top and bottom. So unfortunately, that means you're going to have to do two FOILs. What do you get? What do you get on bottom? 4. What do you get on bottom? Minus 6i. And then move over plus 6i. And 3i times negative 3i squared. What is that? 4. These two cancel out. What is I squared? Times -1. I squared is, so this is going to end up being 4 plus 9. What is 4 plus 9? 13, I think. So that takes care of the I in the denominator. We got rid of it, right? We got rid of the I in the denominator, but now we still need to multiply out that whole big numerator. What do you get? 10 minus 15i, and then move over negative I times 2, negative 2i, negative I times negative 3i. Negative times negative is going to be positive 3i squared, I think. Yes? Now, in the numerator, they don't cancel out. So we get 10 minus 17i plus 3 times, what's I squared? -1. So I get 10 minus 17i, whoopsie, 17i, and then this is going to be take away 3. 10, take away 3. 7 minus 17i. That can't be reduced because they're all primes. Right? Does that make sense? I don't think it's too hard today, right? A lot of work, you know, that foiling stuff, but it's not too bad. So that's how you add, subtract, multiply, and divide. The dividing, you're really not even dividing. It's just multiplying by the conjugate. So we add, subtract, multiply, divide complex numbers today. Does that make sense? Do you have questions? Do you want to see some more examples, or do you think you have it? I think it's not that bad, right? It's not that bad. It's not that bad. Nobody with questions? 95. I had 1 to 35, but I think we'll go 1 to 35 the odds. 1 to 35 the odds. 15 minutes.